Saxon Algebra 1, Lesson 110. We're going to draw a lot of pictures, you guys. This lesson is pretty much just an art project. Okay, we're going to draw a bunch of graphs, and we're going to talk about the shapes that different kinds of equations make when you graph them. And we're going to repeat this lesson next year almost verbatim. So the whole purpose of doing it this time is to stick it in your head so that next year when this all comes back to you, you'll go, oh yeah, I do remember this. All right, and we're going to be drawing 4 little pictures across the top. And I'm going to start by reminding you that these are what we call the parent functions. Okay, I'm not going to start with the vertical shifts. I'm going to start with the parent functions. There are 4 of them. Okay, in my notebook, I'm drawing each one 3 lines up and 3 lines down, and then about the same side to side, and I have to do 4 of them to fill in across the page, and I don't want the last one to always be totally smushed, which happens if I don't plan carefully. All right, this one is what we call the x squared function. And in its simplest form, we're just graphing x squared. And it always takes this shape. It's like a U. And we call that a parabola. I believe we've already talked about this. This was in lesson 95. These are also called, I'm going to write this up here, non-linear functions, which simply means they're graphs of things that aren't lines. All right, we've talked about lines a lot. We're going to talk about them more. But here are some other things, all right? So this is when we have x squared. The next one we're going to consider is x cubed. This is called a cubic function. And it goes like this. Swoopy doop, all right? The next one, I could write x and y on each of these, but you already know that. The next one is called the square root function. It starts there, and it goes like this. Right? And the last one, F, G, H, and then John just jumps to P. I mean, sure, why not? Absolute value function. This one's pretty fun to remember too. It goes right up the middle of each quadrant. All right? These are the parent functions. I'm going to make this even bigger. These are the basic ones. And what we're going to do now is we're going to play with shifting them a bit. We're going to start with the vertical shifts, as I said there. Okay? So let's draw another set of graphs. And let's make 2 more. It's a lot, I know. Because we're going to talk about 2 different kinds of vertical shifts. What we're going to do is we're going to see how do you change the equation to make this shift up? How do you change the equation to make this shift down? So let's do this. Let's shift it up first. Do you see how we've gone from the origin up 1 point? We're calling that 1. This would be f of x equals x squared plus 1. Well, that makes sense, plus 1, right? And it goes up 1. And then if we want to shift it down, we'd say f of x equals x squared minus 1. So this is very logical, isn't it? The vertical shift, if you go up, you do plus 1. If you go down, you do minus 1. All right, we can handle that. And it's just as straightforward for the other functions. Here's our cubic function, x cubed plus 1, because we bumped it up 1. And then let's have it go down 1. And that is g of x equals x cubed minus 1. All right? Vertical shifts are the easiest. That's why we started with them, right? The other ones will get a little kookier. All right, so we can shift up or we can shift down from the origin when we're sliding it up and down the y-axis. And we call that vertical. Vertical's up and down, right? Okay, let's do the same thing with our little square root dude. Okay, I'm trying to draw them so they look the same, but this is an art project, so it's not exactly the same. H of x equals square root of x plus 1. Notice it's on the outside of the pig house. It's not inside, it's on the outside. And then same thing, we can make it down here. Square root of x minus 1, again, on the outside of the pig house. And then our absolute value, p of x equals the absolute value of x plus 1 on the outside. And then down here, p of x equals absolute value of x minus 1. Okay, so very logical, very straightforward. We have our parent functions, and then we have a positive shift and a negative shift. Now, for the next section, we're going to work on horizontal shifts, where we slide it this way, right? We'll start with our same parent functions. So these you have to kind of laser into your brain. But this time, instead of shifting up or down, we're going to shift it left and right. Ah, okay. So flip on over. And let's draw two more rows. Okay, so I'm going to write B horizontal shifts. And again, we're using the same parent function, so it'll be F, G, H, and P, just like we did before. Same order. I have to draw my second row. Okay. So for the first row, let's move them positive. We'll move them to the right. And let's see what happens to the equations. X minus 1 quantity squared. Okay, two things happened. We adjusted this time inside the parentheses. We put that adjusting number and sign right next to the x. For the other one, let's go back and look. For the other one, when we adjusted, we had the x squared. We just tacked a plus 1 on the end. But this time, we're taking that adjusting number and we're scooching it right up next to the x. That's different. Huh. Okay, and now let's look at what happens when we go this way to the minus side. F of x equals x plus 1 quantity squared. So, with horizontal shifts, the sign seems backwards, doesn't it? Doesn't it seem like this should be the positive one and this one should be the negative one? That would make sense, but that's not how it works. So horizontal shifts are a little counterintuitive. You squish the number right up next to the x, and you do the opposite sign of what one would expect. And that plays out exactly the same for all the other functions. So here we go. Here's our cubic function. And that's going to be the g of x equals, again, we squish it up close, and we're counterintuitive with the sign. It's going in the plus direction, so we make it a minus. This is supposed to be just 1 unit. I don't want to make my graph messy by labeling that, but that's how it looks. And then if we want to go negative, the g of x equals x plus 1 quantity cubed. Okay? Counterintuitive with the signs. Our swoosh, it's going to be like that, right? Same thing. This is the FGH of x equals, and then this is the square root. So this time it's x minus 1, and this time notice that our adjusting number is inside the pig house. Remember last time I made a point of telling you it wasn't? This time it is. Negative for a positive shift, and then h of x equals the square root of x plus 1. Okay? Weird. And then absolute values works the very same way. It's the p of x equals absolute value of x minus 1. Again, the adjuster goes right close to the x. All right, and then down here, we'll move it this way. And we say that the p of x equals the absolute value of x plus 1. The number in the sign is weird, and the number and the sign go inside it stays right up against the x. When we come back to these next year, I will give you some more like deeper math thoughts to consider about why this is the way that it is. But for now, I just want you to just put it in your memory as is. Horizontal shifts are counterintuitive with the sign, and the adjusting number and sign go smash up against the x. On the vertical shifts, they kind of mind their own business, right? They stay outside, and they're not so pushy. All right, those are horizontal shifts. Okay. What about reflections? This is a fancy name. Let me write it. Reflections about the x-axis. Make another row. This time we just need 1. 1, 2. We're almost done. We're going to do some problems after this that are short. Okay, what we mean, okay, so here's the x-axis. What we mean by reflections is that instead of being up here, our parent functions were all above. We're going to flip them down. So they'll look like this, right? Remember, we're working off those same parent functions that we had back here, the same basic ones, and we're changing those to make them go down. Now, the cubic one is kind of hard because instead of it just flipping down, we kind of reverse it like that. It's kind of fun to draw. This goes like that, and this one goes like that. Okay? That's what they mean, is that whatever is above you flip below, and whatever was below you flip above. That's the best way to understand this one. Right? Normally it was like this. So this part went up and that part went down. This all goes down, that all goes down. Okay, this is the hardest one to figure out. Now, what happens to the equations when we do this? F of x equals, are you ready? Minus x squared. A minus sign is what flips it. Figures. Those minus signs are trouble, aren't they? F g of x equals minus x cubed. Okay, that's pretty straightforward, right? The h of x equals minus square root of x. So it stays on the outside, right? It doesn't go in the pig house. It stays on the outside. And then this one, this is the p of x equals minus absolute value. Again, it stays on the outside. It doesn't go inside of it. Okay? So we did 3 different kinds of changes. Verticals, up or down. Horizontals, left or right. And reflections, which flip it down. Okay? So now we're going to try a couple problems. Just a few. There aren't many problems to this. Example 110.3. Sketch the graph of f of x equals minus x cubed. Well, shoot, we just did that, right? So we know, okay, I'm going to pretend that's not right there. First, I'm going to do the parent function of x cubed. Oh, yeah, it's like this, right? And then let's think, what does the minus sign do? It reverses it. It flips it upside down. So that means this part will be up and this part will be down. So it'll be like this. So that's my answer. And that's right. And you can put, since the name of this function is f, you can just write f by it. Okay, that's easy, right? That's a place where this functional notation helps us. So that's the answer. And this next problem is going to show us what's called a combination. Oh, I guess I skipped a few problems in here. We'll go back and do them. Let's do, let's leave 104 till we're done. Let's do 104, 110.4. Let's do the first one so that we just get some easy ones in here. 4 is not terrible, but it's a little harder. Sketch the graph of f of x equals absolute value of x plus 3. Okay, absolute value, we know what that is, so we quickly sketch the parent function. It's this one, right? It's flying geese, I call that one because it looks like a flock of geese. You know how they always form a V? So this is flying geese. It's plus 3. The 3 is not, it's chilling on the outside, right? It's not squished in here. That tells us that it is a vertical function, and it means that this plus really means plus. So what I'm going to do, I'm going to draw it like this, and I'm just going to put in a random point, and I'm going to call it 3, and then I'm going to go, okay, it goes from there, right? And I'm going to put an f by that, because that is the name of that function. And guess what? That's the right answer. All right, and then the other one that I skipped, because I was having so much fun drawing, is sketch the graph of f of x equals square root of x minus 3. Okay, I'm going to start with the easy part. I always start by drawing the parent function. This is a square root, so I know it's this deal, right? I always think of this one as the Nike swoosh. So that's the parent. Now, I see that the adjusting number is smushed up next to the x. It's not chilling on the outside like this one. It's smushed up next. This tells me that this one is a horizontal, left or right dealio, and it's opposite sign. And I guess here I would write vertical, and I would write same sign. The sign is logical to me. It moves in the same direction as the sign. This is the wacky one. So that means I'm going to move it in the positive direction and draw it there. Did I get it right? Yes. And we can call that, again, F. John likes to put X and Y on all of these. I think that just clutters it up. That annoys me. If you just draw the plus sign, I don't need you to put the X and Y in there. I want this number, and I want you to label the name of the function. But otherwise, that's fine. Okay, so we got these right. Now we're ready to tackle 104, which is a combo. Sketch the graph of f of x equals, oh, so we can see that we're adjusting the number and we're flipping it. Isn't that clever? Let's start with the parent function. It's absolute value, that's flying geese. Okay, this tells us we're gonna flip it upside down, and this is not attached to the x, so this we know is a vertical function. It's an up and down, and it'll have the same sign. It's not the backwards weird thing. So here we go. That means I'm going to put it, it's going to go down, but it's also going to go, oh no, it's going to go up, isn't it? Up 3, and then like that. Call it F. And P.S., if you do something like this where you start to put it somewhere else, and then you go, wait, no, I don't need that mark. It's fine, just leave it. Don't erase it. Don't ever erase, you guys, please. Don't erase. This is the final answer. And these are the kind of fun ones, these combination. Because you get multiple things going on and you have to kind of think it through. All right, these, if you're a visual person, you're gonna look at these problems and go, this is really easy. It's not a big deal. If you're not a visual person, you're gonna probably feel a little overwhelmed. So we'll find out whether you're visual people or not. I think you both are though, so it should be a piece of cake. That's all I have to say about all of this lovely art. Did you have fun drawing? It's nice. Are we gonna come back to this? Not this year, no. Okay, that's all. Bye.